The first IRBM, or Intermediate Range Ballistic Missile, in the free world was named after the mythological Norse god of thunder. While Thor ruled over the sky, Thor the missile would launch skyward in a thunderous roar. At 65 feet in height and weighing 52.5 tons, Thor was a missile born of the Cold War. America was wary that the Soviet Union would develop a long-range ballistic missile that could strike the nation's vital cities and military installations. So, to prepare, the United States created the Thor. As an intermediate-range missile, Thor would be a step to a longer-range ICBM, or intercontinental ballistic missile. Thus, Thor was given the fast track. Contracts were awarded in December 1955. Thor would pack a nuclear warhead and utilize an inertial guidance system. As a medium-range missile, however, it couldn't be launched from the United States. Thus, Thors would be stationed in England, allowing for a quick retaliatory response if needed.
The base at North Pickenham was home not to bomber aeroplanes, but to intercontinental ballistic missiles armed with nuclear warheads. In those days, most people simply called them rockets, but for the RAF, they were the cutting edge of military technology.
The missile is designed, the Thor missile is designed to carry the deterrent 1,500 nautical miles, well inside the Iron Curtain, and is designed also to be at a state of readiness of 15 minutes.
In October 1956, the first Thor, designated Missile 101, was delivered to Cape Canaveral, Florida, to undergo static firings and propellant tests. Actual launch occurred in January 1957. Seconds after liftoff, the Thor fell back and exploded. Investigation found sandy debris had entered the liquid oxygen fuel hose when it had been dragged along the ground. That resulted in a valve failure. Thor 102 launched in April. The flight was terminated 35 seconds into launch, however, when the missile headed in the wrong direction, over land instead of out to sea. Investigation showed wiring was installed backward, but it flew, and that raised confidence. Missile 103 exploded on the pad prior to launch because of a defective valve. 104 failed a minute and a half into launch. 105, which lifted off in September 1957, less than 2 years after development began, succeeded. 2 more failures followed in 1957, but subsequently, by year's end, 3 successes were achieved. There would be more tests in 1958, some successful, some not. Once deemed operational, Strategic Air Command took control of the Thor missiles when they were deployed to England. They were kept ready to respond if the Soviet Union attacked the United States. Thors were continually on alert until September 1963. By then, the United States had developed ICBMs, which could strike back from American soil. But that's not the whole story. Thors were used in other technological arenas as well. Most prominent to capture the American public's attention was on July 10, 1962, when a 3-stage Thor Delta rocket carried the first Telstar into space. The communications satellite could channel 60 two-way telephone conversations at the same time. For the era, this was an amazing feat.
The Telstar is set aloft from Cape Canaveral atop a Thor Delta rocket in a joint industry-government effort. The Space Administration team handles the launching for AT&T, and it's a $50 million phone call for the telephone company.
It so captivated the public that the British rock group The Tornadoes quickly released their song Telstar. The record hit number 1 on both the British and American charts the same week in December. The Tornadoes would be the first band to reach number 1 on America's Billboard rankings in the pre-Beatles era. By then, however, Telstar had malfunctioned, damaged by radiation from a high-altitude nuclear explosion in November. Telstar 2 followed, and the race was on to orbit communications satellites around planet Earth. Thor would also launch an Echo satellite.
And in inflatable plastic balloon satellite, 100 feet in diameter, tall as a 10-story building, will be sent aloft folded accordion fashion inside a 26.5-inch magnesium container. The latter is mounted in the nose of a 3-stage 92-foot Thor Delta rocket. Highlighting one of the nation's proudest days in space, the satellite, called Echo 1, will serve as a reflector for radio waves that bounce back to Earth, paving the way for a new kind of worldwide communications. The rocket at Cape Canaveral carries the balloon and 30 pounds of powder, which will turn to gas and inflate it at a height above 1,000 miles. At 5:40 a.m., the launching. Then the tense moments while the rocket goes through the separation of the stages. It is only the second launching for the Thor Delta, and as shown in this animated visualization, it is living up to the expectations of the space experts who say it functions almost perfectly. With extremely precise guidance, it is placing the balloon satellite almost exactly into the desired 1,000-mile-high circular orbit. 33 minutes after launching, the balloon is released and inflated by the powder inside, which turns from a solid into gas under the sun's temperature. The big balloon, visible like a bright star, quickly bounces a recorded message by President Eisenhower between stations in California and New Jersey. And here in Washington, the chief executive listens to his own voice as it sounded when bounced from the orbiting satellite.
It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as Echo. This is one more significant step in the United States program of space research and exploration.
And the Courier satellite.
This will be the 100th successful firing of the Thor missile, and it will carry into orbit a satellite even more remarkable than the recent Echo. Unlike the Echo, which mirrors back Earth transmissions, the Courier is equipped to receive and rebroadcast messages from the ground. Marking the 3rd anniversary of the space age, Courier relayed a message from the President to the United Nations, a major stride toward a new worldwide communication system.
Thor nuclear warhead tests did occur. In June 1962, there were 3 flights, the first named Bluegill. When tracking was lost, the missile and the nuclear payload were destroyed.
The first of the Johnston Island high-altitude firings was Bluegill. Ignition of the propulsion system appeared normal. And liftoff was as programmed. The range safety tracking radar lost track, and it was necessary to destroy both missile and the warhead after a long flight on what was later analyzed to have been the correct trajectory.
The second was Starfish. Soon after liftoff, the missile and nuclear device were destroyed.
The next attempted high-altitude shot was Starfish on the 19th of June. It, too, was unsuccessful. This failure was a direct result of special test modifications which had been made to the missile.
Starfish Prime, part of what was called Operation Fishbowl, was successful. Fishbowl was a series of high-altitude nuclear tests under the auspices of Operation Dominic. The thermonuclear warhead on board was detonated at 250 miles in altitude. The next month, the Bluegill Prime payload, which carried plutonium, was destroyed on the launch pad.
The Thor vehicle for Bluegill Prime had a one-of-a-kind casualty, diagnosed as a sticking fuel valve, which caused a fire at motor ignition. Both missile and warhead burned on the launching pad.
Yes, with the versatile Thor as one of the prime tools, man in '58 was pushing back the frontiers of space, doing this with a missile that did not even exist 3 short years before. 3 short years. Speed of development, being ready now, is the big story of Thor. If the need should arise, operational Thors can be uncovered, fueled, erected, and fired within 15 minutes. This is a mighty symbol of the determination of the free peoples of the world to guard that in which they believe.